In this video, we're going to continue working with compositions of functions, but this time, instead of working with functions defined by tables of values, we're going to work with functions defined by formulas. Let's jump straight into some examples. In our example here, we have two functions, a function f defined by f of x equals x squared minus x minus 2, and a function g defined by g of x equals x squared minus 4. Let's get some practice evaluating compositions of functions. In example A, we're looking at f composed with g evaluated at the input 3. Remember, the function that shows up on the left-hand side of the composition symbol is the outer function. The function that shows up on the right-hand side of the composition symbol is the inner function. So by definition, f composed with g evaluated at 3 is f of g of 3. When we have an expression like this, we want to work our way from the inside out. We want to first compute g of 3, take that result, and plug it into the f function. So to compute g of 3, we want to use the formula g of x equals x squared minus 4. So g of 3 would be 3 squared minus 4. And what we want to do is compute f of this result. Now 3 squared minus 4, that's 9 minus 4, which is 5. So we're computing f of 5. Now to compute f of 5, we want to use the formula f of x equals x squared minus x minus 2. So f of 5 would be 5 squared minus 5 minus 2. 5 squared is 25, minus 5, and then minus 2 leaves us with 18. So our composition f composed with g of 3 is equal to 18. Just as a reminder of what this composition represents, let's draw a diagram. When we do f composed with g, we're basically looking at the g function first and then the f function afterwards. When we take any input, we first plug it into the g function. So we took 3, we plugged it into the g function. We got as an output of the g function 5. So we then took the 5, we plugged it into the f function, and that's how we got 18 at the end. Next, let's do the composition the other way around. Let's compute g composed with f of the input 3. This time, g is the outer function and f is the inner function. So by definition, g composed with f of 3 is g of f of 3. To evaluate an expression like this, we want to work our way from the inside out. First, we need to figure out what f of 3 is, and then take the result and plug it into the g function. So let's start with f of 3. Since f of x is x squared minus x minus 2, f of 3 would be 3 squared minus 3 minus 2. And what we want to do is we want to take this output and plug it into our g function. But first, let's simplify. What is 3 squared minus 3 minus 2? That's 9 minus 3 minus 2, which leaves us with 4. So we're actually computing here g of 4. Now, since g of x is x squared minus 4, g of 4 would be 4 squared minus 4, which is 16 minus 4, or 12. So g composed with f of 3 is 12. When we're looking at the composition g composed with f, we're basically taking any input, we're plugging it into the f function first, then taking the result and plugging it into the g function. So when we computed g composed with f of 3, we're taking 3, we plugged it into the f function, and we got 4 as the result. So we then took the 4, we plugged it into the g function, and that's how we got 12 as our final answer. As we've mentioned in our previous video, the order in which we do the composition matters. When we did f composed with g of 3, we got 18, but when we did g composed with f of 3, we got 12. So the two functions, f composed with g and g composed with f, are different functions. Let's now try another composition. In example C here, we have f composed with f of -1. Which means we want to take the input -1, we want to first plug it into the f function, figure out what the output is, and then take that output and plug it into the f function again. So by definition, this is f of f of negative 1. So to evaluate this, let's work our way from the inside out. To compute f of negative 1, we use the formula f of x equals x squared minus x minus 2. So f of negative 1 would be negative 1 squared minus negative 1 minus 2. And what we want to do is we want to take this result and we want to plug it into f. Now, if we do negative 1 squared minus negative 1 and then minus 2, we end up with 0. So really, this is f of 0. Now, if we compute f of 0, this would be 0 squared minus 0 and then minus 2, which ends up being negative 2. So f composed with f of negative 1 is negative 2. Next, we're going to talk about finding the formulas for these compositions. Remember, when we do a composition of functions, we're creating a new function. Our goal is to figure out what is the formula to get the output of my function when I input x. So in example D here, we have f composed with g of x, meaning we want to figure out what's the output of f composed with g when I input x. Our process for this is almost identical with what we did above here. Remember that f composed with g of x means we're looking at f of g of x. And so we can work our way from the inside out. Start with figuring out what g of x is, and then take that result and plug it into the f function. Well, g of x here is given by x squared minus 4. So replace the g of x with x squared minus 4, and what we want to do is we want to plug that into the f function. So now we're looking at f of x squared minus 4. Our function f of x is x squared minus x minus 2. So to evaluate f of x squared minus 4, we simply replace the x's in our formula with our new input x squared minus 4. So this is going to give us x squared minus 4, this whole thing squared, and then minus x squared minus 4 minus 2. Again, all we did was we looked at our formula for f of x, and we replaced the x's with our new input. We replaced the x's here with x squared minus 4's. So this here is the formula for the composition f composed with g. Let's now look at the composition the other way around. Let's find the formula for g composed with f of x. Remember that g is the outer function and f is the inner function. So g composed with f of x is g of f of x. Again, to simplify this expression, we want to work our way from the inside out. On the inside, we have f of x, and the formula for f of x is x squared minus x minus 2. So let's replace that red portion with x squared minus x minus 2. And now what we want to do is we want to plug that into the g function. So now we're looking at the expression g of x squared minus x minus 2. Since g of x is x squared minus 4, if I want to evaluate g of x squared minus x minus 2, I just replace the x with this new input. So g of x squared minus x minus 2 would be x squared minus x minus 2, this whole thing squared, minus 4. So this here is the formula for the composition g composed with f of x. And again, you'll notice that the formulas for these two functions are different. You'll typically end up with different functions if you do the compositions in different orders. Let's take a look at some more examples. In our example here, we have two functions f and g, where f is defined by f of x equals square root of x, and g is defined by g of x equals x squared minus 9. Here we want to find the formula of f composed with g of x. Now remember that f composed with g means f is the outer function and g is the inner function. So this is f of g of x. To find the formula, we work our way from the inside out. So start by replacing g of x with x squared minus 9. So we have x squared minus 9 for g of x, and what we want to do is we want to plug that into the f function. To evaluate f of x squared minus 9, we want to take the square root of x, but replace the x here with our new input. So f of x squared minus 9 would be square root of x squared minus 9. So that's our formula for f composed with g of x. Now let's do the composition the other way around. Let's look at g composed with f of x. This time g is the outer function and f is the inner function. So by definition, this is g of f of x. Let's work our way from the inside out. Start with replacing f of x. F of x is square root of x. So we have square root of x here. And what we want to do is we want to plug this into the g function. G of square root of x, to evaluate this, we want to take the formula for g of x and replace the x here with our new input. So g of square root of x would be square root of x squared minus 9. Now we can simplify this expression a little bit. The square root here and the square can cancel out, giving us just x minus 9. So this is the formula for the composition g composed with f of x. Again, we see that the function f composed with g is different than the function g composed with f. However, sometimes f composed with g and g composed with f can be the same function. We'll see this happen when we work with inverse functions. As a preview of this, let's consider the following example. Here we have two functions f and g, where f is defined by f of x equals 2 minus 5x, and g is defined by g of x equals 1/5 times 2 minus x. What we're asked to do is to check that f composed with g of x is the same as g composed with f of x. So let's figure out the formula for f composed with g of x, and then we'll figure out the formula for g composed with f of x, and check that we end up with the same thing. So starting with f composed with g of x, we're looking at f of g of x. First, let's replace g of x with 1/5 times 2 minus x. So we have, instead of g, we have 1/5 times 2 minus x. And what we want to do is plug that into the f function. So in my f function, let's replace the x here with my new input. So f of 1/5 times 2 minus x would be 2 minus 5 times 1/5 times 2 minus x. So this here is the formula for f composed with g of x. But we can simplify this a little bit. For example, we see that we have a 5 times 1/5, which means that these two factors can cancel each other out, leaving us with 2 minus 2 minus x. If we distribute this minus sign, we'll end up with 2 minus 2 plus x, and we see here that the 2 and the negative 2 will cancel out, so in the end, our formula is just x. Now let's do the composition the other way. Let's look at g composed with f of x. This time g is the outer function and f is the inner function, so g composed with f of x is g of f of x. So let's simplify this. We can replace the f of x here with 2 minus 5x. So write down 2 minus 5x, and what we want to do is we want to plug that into the g function. So g of 2 minus 5x, we would look at the formula for g of x and replace the x with this new input. So g of 2 minus 5x is going to be 1/5 times 2 minus 5x. So this here is the formula for g composed with f of x. Right now, it doesn't quite look like the formula for f composed with g, but maybe we can simplify this a little bit. We can start by distributing this minus sign here. That's going to give us 1/5 times 2 minus 2 plus 5x. And we see here that the 2 and the minus 2 will cancel each other out, leaving us with 1/5 times 5x. And here, the 1/5 factor will cancel out with the 5, leaving us with just x again. So we see here that g composed with f of x is x. And we see that for these particular functions, when we do the composition f composed with g and g composed with f, we end up with the same function either way. So, in this video, we learned how to evaluate compositions of functions, and we also learned how to find the formulas for compositions of functions.